So we'll take a look at the experimental results from yesterday's lab with trying to freeze that monster drink. And I'm going to make a couple of assumptions. First of all, I'm going to say you started with a 15 ml sample. Now, I did a couple of measurements, and these are going to be necessary for your experiment. So we're going to say that the density of the solution, density of the monster, I measured that to be 1.0542 grams per milliliter. So that is, I took a 50 milliliter sample at a weight, it was a little more than 50 grams, so I divided the two and I came up with that number. So let's say that you start with a 15 ml sample. I want to find the mass of solution. That is the mass of the monster drink. So if you have a 15 ml sample, you might be different. Maybe you chose 10. So I can do a little dimensional analysis, 1.0542 grams for every 1 milliliter. When I multiply that out, I get 15.813 grams. Okay, so that's the mass of the solution. To find the mass of the sugar in that solution, we can use the can. The can said you have 27 grams of sugar, C12H22O11, in 240 milliliters. So that's right from the can. If I was to multiply that by my 15 ml sample that I tested, that would give me the mass of sugar. And that mass of sugar is 1.6875 grams of C12H22O11. I'll need to use that when I find the moles, because that will allow me to find the molality. But again, you're going to choose your volume, put it here, and then you're going to compute the mass of sugar. We also need to know the mass of water in this experiment. And I can find that by taking the difference between these two. See, that's the mass of the solution, which is the sugar plus the water, and this is just the sugar. So if I take 15.813 grams and I subtract 1.6875 grams, I'm going to come up with a total of 14.1255 grams of water. Remember, molality says we have to convert that to kilograms. So then that would be equivalent to 3 places to the left, 0.0141255 kilograms of water. Okay, so another piece. Next step is to find the moles of sugar. So the moles of sugar are going to be found by taking the mass of sugar, which we found from this step, 1.6875, and then we need to divide that by the molar mass. And if you figure it out for C12H22O11, I think that's 342 grams in 1 mole. Okay, so we divide those out. We get a small number. It's 0.00493 moles of C12H22O11. Okay, next step is in order to get the freezing point depression, we need to find the molality. So the molality, you might remember, is the moles of solute per kilogram of solvent. We have both of those numbers. Moles of solute from the previous step. And the kilograms of solvent from the previous step, 0.014. That's the water. I divide those out, I get 0.349 molal. Okay, almost there. Now we can predict our freezing point depression by taking delta TF is equal to KF times the molality. Important, important, important. The KF is for the solvent, and that's in your text somewhere around page 438. Page 438. we find that Kf is negative 1.86 degrees Celsius per molal. I multiply that by my concentration, 0.349, and I'm going to get negative 0.65 degrees Celsius. So it should be that much lower than 0. Remember our graph? So if it drops, K does this and falls again, and then with the solute, with the sugar dissolved, it's lower, so that's the delta TF. You did your measurements in the lab yesterday using distilled water, so let's say that that one was going to be 0 degrees Celsius when you use distilled, and let's say, as just an example, that you measured from the second graph with the monster, let's say that that was negative 0.55 degrees Celsius. So not exactly what we predicted, but it rarely is, right? We're never 100%, so we can hopefully get close. I want to do percent error now. This is the last thing for your lab. To find the percent error, you take the actual minus the theoretical over the theoretical times 100. We will let this calculation here, the delta TF, we'll say that that's the theoretical. And we'll say that what you measured, this is the actual. Now I'm going to do it with absolute values. The negative signs can be a mess. So let's just make them positive and do their differences, okay? So that actual is 0.55 if we did the absolute value. The theoretical is 0.65, and our theoretical is 0.65. Multiply that by 100, and you'll get a percent error of something like 15.4 according to these numbers. Okay? So that's what I'd like you to add to this experiment for submission. Feel free to review the video if that's helpful. Have a good day.